Welcome to today's webcast on the dollars and cents of rugged laptop computers for aerospace and defense applications, brought to you by Military and Aerospace Electronics Online. Today's event, sponsored by Panasonic and Microsoft, focuses on the advantages and disadvantages of using ruggedized or commercial-grade laptop computers for military applications in demanding conditions. Our presenter today is Kip Walls, Director of Product Management at Panasonic System Communications Company of North America, maker of the well-known Toughbook rugged computer. He will tell us about the considerations and trade-offs of using ruggedized laptop computers in harsh battlefield conditions versus using relatively inexpensive commercial-grade laptops that can be discarded when they fail in the field. Before we begin, we would like to cover a few housekeeping items. At the bottom of your audience console are multiple application widgets that you can use. If you have any questions during the webcast, you can click on the Q&A widget and submit your question. We'll try to answer these questions during the live Q&A portion at the end of this webcast. You can expand the slide area by clicking on the Maximize icon on the top right of the slide area, or by dragging the bottom right corner to enlarge. In fact, you can expand and reposition many of the components of your screen, so please feel free to arrange as you would like. If you have any technical difficulties during the webcast, please click on the Help widget. It has a question mark icon and addresses common technical issues. If you still need assistance, just type your issue into the Q&A widget, and a member of our webcast support team will work with you to correct the problem. For your convenience, this presentation will be available on demand within 24 hours of this live event. A reminder email message will be sent to all registrants with a link to the archive. It also will be accessible from our homepage at www.militaryaerospace.com. So, let's get started. I'll turn it over to Kip Walls of Panasonic. Kip?
Thank you, John. Thank you, ladies and gentlemen, for joining us today. Let me start off by telling you a little bit about myself and about Panasonic, specifically the part of Panasonic that supplies military customers and system integrators and corporate customers. Again, my name is Kip Walls. I'm a 26-year veteran of the mobile computing space, 16 years with Panasonic. Panasonic as a company was founded in 1918. We're soon coming up on our 100th anniversary. As John alluded to, we are a global leader in both rugged laptops with the Toughbook line of products, as well as rugged tablets with the ToughPad line of tablet products. We've been in the enterprise mobility space since 1996. We're a little unusual from the perspective that we have 100% ownership, not only of product design, but also of manufacturing, testing, support, deployment, and services on all Toughbook and ToughPad products. And a lot of people don't know the fact that we have about 80% of our business in North America right now is focused on B2B. People tend to think of Panasonic as a company that makes microwave ovens and television sets, but an awful lot of the business over the last few years has really switched to B2B and B2G, and so it's the lion's share of our business now. I'd like to do a quick poll and see which branch of the government you either work in or you support. And so if you look on your screen there, you have a choice of agencies or branches that you can click there. If you wouldn't mind clicking on that slide and then clicking Submit, we'll take a look and see what kind of audience we have here, and hopefully we'll be able to tailor our comments to meet the majority of your needs. So I'll give you a couple of seconds to do that. you'll see that there's choices running through the 4 major services: DoD, General, Fed Civilian, Homeland Security, and others. So if you click that and hit submit, let's take a look and see who we have joining us today. So it looks like fairly even split between Army, Navy, Air Force, and DoD in general. A lot of other, not so much on the Homeland Security or Federal Civilian side. So that's good. We're talking to a mostly military audience here today. A lot of other, which hopefully is our folks who have just a general interest in rugged computing technology. And speaking of that, another poll question. We'll be interested to know whether you're currently using rugged mobile computers in your agency or the agency you support. So if you click on either yes, no, or if you don't know, there's an option for that too. You can click submit. And I'll give you a second to do that. That should be a fairly quick one. And then let me take you to the agenda and show you what we're going to be talking about today. We're going to be talking about some of the market conditions that are happening in military. We're going to be looking at some project and technology drivers, some military mobile computing must-haves, some things that you really ought to be considering when you're looking at computing in the field. We'll talk about how you achieve a low total cost of ownership with rugged computing, and then we'll have an opportunity for some questions and answers. First off, let me talk about the market. Clearly, technology is important, but if the partner that you're working with doesn't know your market, they're probably not going to be much of a partner. So let's take a moment and set the stage, if we can. Some of the things that are happening in the market specifically are some pressures that are actually happening in military, and a few of those include, how militaries transition to the future. Because as you weigh your investment in efficiency driving technologies to benefit the advanced warfighter, you need to think about where those investments come. And a lot of military organizations are creating strategies and roadmaps to leverage both legacy systems and new technology, including things like big data, mobility, cloud, and social, to provide innovative and improved services for their warfighters. From a budget perspective, the military is facing ever-increasing pressure to cut costs and to do more with less. In reality, reduced budgets are really the new normal, and federal IT spending is most likely to hold relatively steady during the next 5 years, despite major shifts in government spending elsewhere and transformations within the IT industry. From a performance management perspective, there's increasing pressure to monitor and improve performance in light of these budget challenges and a number of high-profile failures. Cost reduction is one aspect, as well as meeting performance metrics and really citizen and congressional expectations. And standards are also likely to play a key role going forward. From a data breach perspective, data breaches and hackers are a constant threat, and they require enhanced security to provide, to protect valuable government data. And federal policies really place strict regulations on security when it comes to mobile devices to ensure that data is protected. And then finally, when it comes to the private sector, in a lot of cases, the focus is on deployment of technologies that have already proven their worth in the public sector, and this helps to not only to drive innovation in federal government, but it also helps to retain high-quality employees and service members. Another aspect of what's happening in the industry, really, it's becoming more and more about the data. Data is really the center of decision-making in today's armed forces. And this is only going to grow the emergence of the Internet of Things, or sometimes referred to as the Internet of Everything, and machine-to-machine communications between physical objects like personnel carriers, weapons, and unmanned vehicles. And as more devices are connected, we're seeing data, there's an opportunity to seek data from all these available sources. And as Lieutenant General Michael Oates, who's the head of the Joint IED organization, stated, there's no shortage of data, there's a dearth of analysis. So the increase in data really creates a need for solutions that can interpret all the information effectively and get it out into the hands of people who can use it. And then in order to protect soldiers and make intelligence more actionable, the data is available when and where it's needed, both without sacrificing security and with the ability to manage these complex systems. So when we talk about mobility, to take advantage of this data and respond to these market pressures, we really feel that mobility is going to be central to success. Mobility technology is not new to the armed services, but service members are being asked to do more, to be more mobile than they ever have before, and taking mobility even further into the field. So we're seeing more job functions become mobile. In many cases, pen and paper jobs have been replaced by tablets. Service members that have become more mobile are becoming more reliant on the data they collect and more reliant on the data that they're accessing. So that makes connectivity more crucial than ever. And we can't overlook something that's on everyone's minds. While mobility is critical, it means that more devices with more potentially confidential data out in the field, so managing the security of these devices and their data is really paramount. So it's clear the market is changing. The mobility and data are becoming even more important. So with that in mind, many federal customers are looking at how mobility can improve their workforce and increase the available data collection points or mobilize those data collection points. So when we think about mobility technology, there are often a number of project and technology drivers to consider. So let's look at some of the key drivers behind mobile technology deployments in the armed forces and the types of operations they're trying to impact. I want to talk today specifically about three project drivers, including an elevated need for productivity and efficiency, some improved communications, and reducing a total cost of ownership, because really rugged mobile devices can work in all environments, and they can really save money through a lower total cost of ownership, as we'll talk more about here in a second. From an efficiency perspective, military leaders are facing the challenges of fulfilling mission-critical goals while simultaneously coping with reduced workforces and with the necessity of allocating funds to only the most vital resources. And mobile technology can make it easier to collect, store, and transfer data, and it helps service members work more efficiently. A recent survey of 300 federal managers by AOL Government found that mobility would greatly improve productivity and decision-making, and about half of them indicated that a typical federal employee would gain at least 7 hours of productivity per week if they had access to mobile technology while on the job. That's a pretty substantial productivity improvement. When we're talking about communications, mobile tech will keep service members connected on and off the battlefield to access the information and the tools they need to do their jobs. So that will always improve decision making at the decision point. And then when you're talking about lowering the total cost of ownership, when you lower TCO and you achieve the best value with limited funding, that can really make a project much more palatable. But unfortunately, this leads some customers to consider consumer devices. But generally, these are going to be inappropriate in the environments that we're talking about. And some of the reasons for that are that consumer-grade tablets, while they might have a lower sticker price initially an enterprise-grade device will provide investment protection and lower the total cost of ownership when you measure the lifetime of the device and not just the initial purchase time. Also, enterprise-grade devices are more durable for extreme environments. They're more feature-packed, and they're easier to integrate into an existing infrastructure. And consumer-grade devices are not designed to meet the strict security requirements of the DoD, nor are they really durable or reliable for the job. So these devices really need to be replaced more often, and those replacement schedules can disrupt workflows, lower productivity, and can even lead to mission failure. And so when you're looking at enterprise-grade devices with mil standard 810G and ingress protection or IP ratings, they're guaranteed to withstand a range of abuse and environmental conditions. It gives them a longer lifespan, and it'll ultimately save the agency money. So what do customers need from technology for the deployment to be considered successful? Let's look at some of those things. First, from a security perspective, the recent data breach in the Office of Personnel Management, they now believe they have compromised personal data on over 22 million current and past federal employees, and this may include financial data, information about family and friends, other sensitive details, including, it now looks like, maybe more than 1 million sets of fingerprints. So security hacks are going to be a constant threat for defense agencies, and they're going to need reliable cybersecurity to protect this vast amount of valuable data that they protect. From a mission readiness perspective, when you're looking at technology that was not designed for the kinds of environments that these units will be used, the solution will rarely meet its full potential. Panasonic is currently the only laptop manufacturer to make its failure rates public. We actually share our service records for units both in and out of warranty, and we show an average annual failure rate of only about 2.5% for toughbook and toughpad models. From a reliability perspective, your technology has to be able to hold up even in battlefield conditions, and so that's going to be a lot of different environments and a lot of different stuff that's going to get thrown at that, and even things as seemingly innocuous as a bright sunny day can really have some impact on how the device can be used. From a device performance perspective, we believe that mobile devices really are going to have to deliver performance that is going to meet the needs of both the agency that's deploying it and the end user who has the equipment in hand. And of course, performance like connectivity can actually be more important today than even things like historical measures like processor speed or something like that. From a budgeting and funding perspective, the funding that is going to be secured is going to need to have a solid argument for the value of that technology. And one way to do that is to consider things like longer technology life cycles instead of deploying units for 2 to 3 or maybe even 4 years, having life cycles of 5 to 7 years with the corresponding longer part availabilities. All of those things can lead to product that is less expensive to own over time. And one of the things that you need to be mindful of is that it's not about the purchase price, but it's about the total cost of the solution over the lifespan of that product. There are deployment challenges that need to be kept in mind because most mobile initiatives really are sitting at that mesh point of both operations, wireless, devices, user training and expectations. And if you don't have a lot of experience with doing deployments, don't know what best practices are, and don't know how to adjust the culture to break down silos and to implement mobile technology within the workforce, it's much less likely to be a successful deployment. Let's look at a couple of things that we think that military mobility really beyond technology and product drivers, what some of the things that you should look for in a partner, because really selecting the right partner is as critical to success, maybe even more so, than picking the right technology. So we really believe that having the right device is going to have significant benefits in terms of our productivity, operational efficiencies, job confidence, return on investment, and mission success. And so we actually have at Panasonic designed our products with three key audiences in mind. And rugged computers really do need to be designed with the idea of the worker, the IT team, and procurement and finance, all of those in mind. So let's think for a second about the value to the worker or the warfighter themselves. Rugged mobile computers are really purpose-built for mobile workers. They're not consumer devices that are being placed in commercial environments. And because the military has critical requirements for its mobile equipment, including the need for technology that can be dropped, that is spill-proof, that can withstand extreme temperatures, vibration, and other kind of factors, we have built Panasonic ToughBook and ToughGuide products with the idea that they are, the specific idea they're going to be used in these kinds of environments. So, things like daylight viewability really make the product, much more usable in a wide variety of circumstances. And as we see more wireless usage within the military, that connectivity piece can make a huge difference. So Panasonic has made an enormous investment in wireless testing chambers and infrastructure that helps us to design wireless antennas and to place the antennas and the radios within the machines so that we get far better coverage, especially in fringe areas, than any other manufacturer, because we recognize that you're not always going to be sitting right underneath a cell tower or within eyesight of an access point, and you're going to need to be able to connect and get the data that you need. And even things as obvious as accessible batteries, the ability to swap and use a battery when your battery is depleted and not have to go plug in, as many consumer devices would require you to do, can make a huge difference in terms of the usability of a product. When it comes to IT, they are, a key part of most decisions here. So, we like to talk about our value to the IT team. And because even nowadays, they're often tasked with doing more with less. So, that challenging of managing and supporting mobile project can really be significant. So, as a rugged device maker, we know that security is a major concern. We've been helping both our government and our enterprise business customers manage this concern for years, because really in the military, missing or compromised data, don't just lead to a loss of money, but it actually can lead to a loss of lives. So, protecting data is a constant problem for DoD, and, that happens whether you're talking about, mobile computers, barcode scanners, any other kind of technology. So we've built a lot of security capabilities into our machines to make sure that they're going to hold up in from a security perspective and provide that data security that's so critical. From a support perspective, I sometimes refer to this this list here as kind of our Cheesecake Factory menu of choices, because there's an enormous number of support services that we can bring to bear for an IT department. And so, when you're talking about the challenges that you're faced with the deployment or management of mobile technology, Panasonic is uniquely positioned to work with an IT department to do things not only from a deployment and a mobile device management perspective, but even things like staff training, vehicle installations, and in-field support, even in places like the Middle East. And one of the things that I like to point out on here is that Panasonic employs a large number of on-site field engineers. We actually have about 40 of them nationwide in the U.S., and those engineers are tasked with doing nothing but working with large customers to help them address issues that unfortunately oftentimes pop up in a large deployment. And so instead of just having somebody to talk to on the phone, we actually have people who can come out, work directly with an IT team to address the issues that they may be having and solve those problems for them. And then, another significant difference between a Panasonic ToughPad solution and a consumer tablet is the fact that you're looking at 3 to 5 year warranty terms for a Panasonic ToughPad. And if you contrast that to a 90 day to 1 year warranty that you might find on a consumer product, it's clear that if you're going to achieve those long-term deployments, that you're going to need a warranty that's going to last a lot longer than the 3 or 12-month warranty that a consumer product would have, and that is not going to be practical for most mission-critical environments. So we like to say that the right partner and the right technology can really shift the IT team away from a constant focus on technology support issues, which is so frequently the case today, and to its true purpose, which is to find ways that technology can help achieve the organization's mission and not spend all of their time just handling phone calls from disgruntled users or break-fix kinds of issues. And of course, if you can't make a financial argument for an IT solution, you're probably not going to succeed in funding it. So let's look at that. Let's talk specifically about what rugged mobile computers bring to the table from a financial standpoint. One of the things that is absolutely key to achieving a low total cost of ownership is very high reliability. And in this chart, you can see that the industry average annual failure rate for laptops used at work is sitting at about 13%. Now that's against Panasonic's average, which is a little less than 2.5%. And when you consider that Panasonic's products are being used in some of the most demanding environments in the world, and certainly much more demanding than you would find in most of our competitors' environments, that it's truly remarkable that our failure rates are so much lower. But that is partially a function of the fact that, as I mentioned earlier, we have control of design, manufacture, test, verification, support and deployment. So it helps us to deliver those much lower failure rates. And of course, they're also supported by things like shock-mounted hard drives, magnesium alloy casework, chemically strengthened glass, all of the things that make our machines hold up better than competitors will out in the field. And the same trend can really be seen in the tablet world. Data from VDC Research, an analyst firm, shows that consumer tablets have about an 18% annual failure rate, which means that nearly 1 in 5 of these tablets is going to break down on its user every year. And by contrast, rugged tablets have a failure rate that's a fraction of that. And I can tell you that Panasonic's rugged tablets, the ToughPad tablets, this is an industry number at 4%, have actually a lower failure rate than that. And lower failure rates actually lead to less downtime, to fewer repairs, and a lower total cost of ownership. And if you look over the life of a typical mobile computer, that can add up to substantial savings, not to mention a better overall user experience. In fact, VDC reports that for each 1% increase in the device failure rate, you should expect to see a 5% increase in the total cost of ownership. So you need to take that into consideration when you're thinking about what's the most economical alternative for you as you're looking at deploying stuff in military-grade sorts of environments. So acquisition cost, purchase price, which is typically what people look at because it's one of the easiest things to identify, is really just one part of the equation. And in fact, according to VDC, the research firm, it's really just the tip of the iceberg, because 70% of costs associated with mobile deployments over its lifetime are life cycle costs, not acquisition costs, and most of these costs are soft costs, though there are some hard costs also, and they have a major impact on the overall performance and of the solution and the total cost of ownership. So when you're looking at trying to find the true cost of mobility, you have to include things like support time, any time that the computer doesn't perform as it's needed to do, and from downtime when the user stops doing the job that they're supposed to be doing and starts playing field support technician. So costs have to take into account the impact of operational inefficiencies too that can come from using a technology that really isn't suited for the environment in which it's being used. For example, if you can't see the screen in the sun, it's going to cause somebody to stop working until they can seek some shade or move inside. That has an impact on efficiencies. If you've got poor integrated wireless connectivity and you got a reduced signal, that's going to impede a worker's ability to connect to the data network and perhaps get mission critical information. And I remember hearing one of our Air Force reps tell a story about a purchasing agent that she was talking to in the U.S. Air Force. And this woman was relating to her how an airman had called in on a sat phone saying that his commercial grade non-toughbook laptop had failed, and the failure of that laptop was causing the entire mission to fail. And the airman was a wreck because he knew that this mission could not succeed without his laptop working. And she said after that day she would never send an airman or any of the personnel that she was supporting into a mission critical situation with anything less than a Panasonic Toughbook or ToughPad solution to support them. So if you look at downtime that is which is tied to device failure, you really need to account for that. So consumer device makers will typically try to shift the purchase to or shift the focus to just the purchase price alone, and they'll say that we'll improve your total cost of ownership, and they say they'll do that by offering discounts and price cuts. But we know that these price gaps that make the rugged mobile computer appear more expensive are really just not accurate, because while a rugged mobile computer that is purpose-built for mobile environments and that leads to greater operational efficiencies because the users have the right tool for the right job. And we've talked about how rugged mobile computers require less IT support, and they have reduced downtime, which means both more opportunities for use of the equipment and reduced costs there, that ultimately rugged mobile computers deliver more savings and a lower total cost of ownership, which equals both a higher return on your technology investment and happier users, which also will make the procurement department happy. So we appreciate your taking the time to come join us and to give us an opportunity to share some of this information with you. It's a common misconception that you can actually save money by buying lower priced equipment. And when people say to me that I could buy 3 iPads and rugged cases for the cost of a single ToughPad tablet computer, I always tell them that the only way you're going to save money is if you buy all 3 of those iPads with their rugged cases at once, and when those iPads break, which they will, that you immediately pick up the next iPad and continue working. Because the second your user starts playing field support person, trying to figure out why the iPad isn't operating, and then places the phone call to IT, and the IT department starts trying to troubleshoot that product, and then they schedule a time to get a replacement unit out. Within minutes of that first failure happening, the cost of ownership on that inexpensive consumer device, on that inexpensive iPad, just went through the roof. And many of you have probably had the experiences, I know some of my friends had, that using an iPad out of doors, if you put it down even in the shade on a hot day, the first generation iPads, when they overheated, they turned into bricks. The only way to fix them was to replace them. The current generation of iPads, when they overheat, they merely shut down, and after they cool down, they'll start up again. But if that time that they're shut down is the time when you need critical information off of that tablet, it's going to make a huge difference in terms of operational efficiency and indeed even mission success. So we're hoping that you can see that a rugged solution, especially a Panasonic rugged solution, is going to provide you with that return on investment that you so desperately seek, and will actually wind up saving you money over time versus a quote-unquote less expensive solution in terms of a consumer tablet. So at this point, John, I think we're ready to take any questions that our audience may have and see if we can't try to answer those.
Okay, well, thank you, Kip. And as you mentioned, now it's time for questions from our online audience. You can submit questions at any time by clicking on the Q&A widget and submit your questions. And if you don't mind, before we start with the audience's questions, I have a concern myself, and it's basically, how do you characterize the cost of field failures? and not only in terms of lost productivity and increasing total cost of ownership, but more in terms of mission failure, and maybe even more important than that, the potential for the loss of critical or irreplaceable data in the field. I mean, how do you impress on people about the real and immediate costs of a computer failure in the field?
Well, John, that is a great question, and the reality is that we tend to think of the expense of failure being the replacement of the hardware, but the real expense is oftentimes much higher because it can be the loss of critical data. And so one of the things that we do at Panasonic is we protect the drives in our machines to an almost ridiculous extent, to the point where Panasonic engineers actually invented a type of foam rubber. We call it super sheet technology. Panasonic invests nearly $4 billion a year in R&D, and one of those R&D efforts gave us super sheet technology, which is a foam rubber that compresses a lot less than standard foam rubber does. And we actually take the hard drives in our rugged laptops and wrap them in two different kinds of foam rubber, standard foam rubber and super sheet technology, so that if a machine is dropped or something is dropped on the machine, or even if the hard drive is removed from the machine, a lot of our DoD customers will pop out the hard drives to secure them separate from the machines, and that helps from a data security perspective. But if that hard drive is dropped, picked up, and then immediately dropped again accidentally, the foam rubber that protected the drive in the first drop might not have recovered quickly enough to provide protection in the case of a second drop. And so two types of foam will allow you to do that. And that's the kinds of extents that we go to protect data on a drive. Even solid-state drives that people tend to think are all highly reliable because they're solid-state. There's no moving parts. What we've seen in our testing is that a lot of our competitors, especially those on the consumer side, are using solid-state drives that in the case of a drop, you can actually have chip separation from the board that represents the base of the solid-state drive. And in that situation, you can damage the solid-state drive and lose the data even in that drive. A lot of people also don't know that solid-state drives are subject to, at very low temperatures, below zero, are subject to a phenomenon called data migration, where data will actually migrate between the cells on the solid-state drive. So on the tough pad products that employ solid-state drives that we build, we use drive heaters so that the drive will not experience data migration if it's used in very low temperatures. And so, you can have data loss from damage, but you can also have data loss from corruption. And as you point out, John, the value of that data can far exceed anything in terms of the cost of the hardware. So being aware of those types of things and understanding the demands of the environment where they're going to be used can really make a huge difference in terms of protecting that data and making sure that that the data is being treated as valuably as the hardware that it's being stored on.
Okay, we've got a question from the audience. Are there any efforts being taken at Panasonic to protect the computer and its data from electromagnetic pulse or other types of EMP-like phenomena?
Well, interesting that you would ask that question. Obviously, there is more and more of that type of thing, those types of weapons being developed. And one of the things that protects electronics from an EMP is enclosing it in a metal box. And the casework that we use on the Panasonic laptops, Panasonic Toughbook rugged laptops, and even the cases on our Panasonic ToughPad tablets are made of magnesium alloy. Now, the main reason we use magnesium alloy, even though it's relatively expensive and it's very difficult to mold, it has to be molded at incredibly high levels of pressure. It is much stronger by weight than either aluminum or titanium. And so by using magnesium alloy, we provide thinner, lighter cases, but much stronger. But sort of a side benefit of that is that you're seeing some benefit in terms of protecting electronics, the electronics inside the machine, from an electromagnetic pulse. I will say that we do not do currently EMP testing on our devices, so that is not a certification that we provide for either the Toughbook or ToughPad laptops or tablets. But you're going to see a higher level of protection from an EMP in a metal-cased Toughbook or ToughPad than you would from virtually any other device, unless that device also has an all-metal case to it.
Okay, question from the audience, and that is the technology between rugged and non-rugged computers, is it basically the same? And what are some of the inside-the-box type of design factors that help differentiate, a ruggedized computer like a Toughbook from a non-ruggedized commercial-grade laptop?
So there used to be a huge difference in technology in terms of rugged versus non-rugged, and one of the reasons for that was because rugged devices tended to have, fairly, a couple of 3 generation old technology in them, and there wasn't a lot of, wasn't nearly as much development being done on those. Panasonic sort of rewrote those rules when we really started to do rugged laptops with the first fully rugged Panasonic Toughbook, the Toughbook 25, about 18 years ago. And because we work very closely with Intel, nowadays when Intel introduces a new chip, we generally have that new chip in our machines about the same time that the commercial laptops will. So there's not a big step down or degradation in terms of performance, other than the fact that some of the consumer grade gamer machines that have extremely high-speed processors, quad cores that throw off a lot of heat, it would be very difficult to manage the thermals inside of a rugged sealed device with that kind of chip in there. So you're looking at, from a technology perspective, rugged laptops and tablets today are very comparable to other mainstream laptops and tablets, but probably not as fast or robust as you would with a gaming laptop or perhaps certain engineering workstations. But the real difference in technology is not so much in terms of storage or RAM or CPU. It's really more in the way that the technology inside the machine is protected. So at Panasonic, even our semi-rugged machines will have spill-through keyboards, will have sealed port covers, other things that will protect that device from the elements. Semi-viewability is another key difference between a standard commercial laptop and a rugged laptop. We understand that our machines are going to be used outside not only in bad weather, where they have to be able to hold up to a driving rainstorm, but also in nice, sunny, bright weather. And so sunlight viewability, the ability to be able to see the screen in bright sunlight. And we do that through a number of different technologies, extremely bright displays with very high nit ratings or brightness levels on them, special anti-glare, anti-reflective technologies that really knock down the amount of reflection coming off the screen. John, if you think of a lot of laptops you see that have these very glossy screens that look great for watching movies, but when you take them outside, it's kind of like looking at a mirror. We have the polar opposite of those with machines that throw off very little reflection, and so much better to use, to look at in direct sunlight. So those are a couple of the differences in technology. I talked about how we shock mount the hard drives and even the solid-state drives. Commercial machines, you'll hear sometimes people say, well, we have a technology with an accelerometer that will park the heads on the hard drive if the machine drops. And while that is definitely an improvement over a machine without an accelerometer, one of the things we realized very early on was that our shock mounting technology was much more effective in protecting the machine, not only in a drop, but also if something is dropped onto the machine. So if a tool or even a cup of coffee is dropped onto a machine that has an accelerometer in it, the machine never saw that force coming, and so you can have a situation where the heads can hit the platters and destroy the drive. But with the shock mounting technology we're actually able to protect the machine not only in a drop, but in the case of something being dropped on it. So it's a lot of thoughtful, distinct measures that you take to make sure that a rugged machine is going to work in environments that commercial machines, frankly, are not designed for. And one of the reasons that a commercial machine or a consumer machine is cheaper is because there are economies of scale to building these volumes of machines that are just going to go out for corporate standards or for use by people like my mother in her living room, but were never intended to be used in challenging or demanding environments. And a lot of people think that if you take a consumer tablet and wrap it in a rugged carrying case, or a rugged case, even a user case, that it's going to give you the same kind of performance as a fully rugged tablet. And obviously, it's not going to have any impact on things like sunlight viewability. It doesn't help with that. And it's probably not only not going to help you, it's probably going to hurt you in terms of providing an insulating layer that's going to make the machine even hotter in high temperatures. But it turns out in the testing that we've done, it turns out that the drop protection isn't nearly as good as people would need it to be. And I don't know that people realize that when we do drop testing, using the mill standard 810G drop test technology, we drop a machine 26 times onto every edge, corner, side, and face. And when we pass them with Panasonic Toughbook and Tough Guy products, we pass those 26 drops with a single machine. We're not using multiple machines to get our drop rating. We're doing a single machine, all 26 drops, and the machine not only does it have to operate, it has to be not damaged. So we really, people would accuse us of over-engineering our machines, but we don't think we can over-engineer a solution that has the potential of saving a life if it's working properly.
Okay, I've got a question here from the. That's all right. Got a question from the audience that I believe speaks to the notions of anti-tamper, anti-theft. If you have a tough book that's been used by the military in the field and somehow is lost or captured, or some of these bad things that can happen, are there provisions in the design of the machine that can help protect the potentially sensitive data stored on that machine from from an adversary who might seek to recover it and use it against us?
We do actually have some measures that we take with that. We work with a company that you may be familiar with called CompuTrace. It provides a piece of software called, sometimes referred to as LoJack for laptops. But CompuTrace, actually Absolute Software is the name of the company. CompuTrace is the name of the software. And CompuTrace technologies allow us to, if a machine goes lost or stolen, to reach out and essentially brick that machine to erase all the data and make it non-operating. Plus, working with Intel anti-theft technology, you can actually set up your devices so that if they're not logged into on the network in a certain time frame, that the data will be wiped. So we do a number of things to make sure that that products are not lost or stolen in the first place. But with things like fingerprint scanners, with smart card or CAC card readers that help to secure the contents of a drive or a machine, not to mention things like CompuTrace from Absolute or the Intel anti-theft technology, which allows you to make sure that once you do know a machine has gone missing, that you can either reach out and destroy the data with a poison pill, or where the machine can destroy the data automatically. That goes a long way to making sure that data does not fall into the wrong hands.
Sure. Okay. Well, at the risk of stirring up some controversy, I've got a question from one of your competitors, and that is, my customer has seen another competitor's ruggedized laptop and is impressed with their use of bumpers. Have you done a comparison of the Toughbook design against the one offered by GTAC and other ruggedized computer makers?
Yeah, we actually have done a number of comparisons against all of our rugged competitors, and there's a reason that Panasonic has 84% market share in the fully rugged space. Bumpers, it's interesting that the question included the term bumpers, because people often think that bumpers are providing you with a level of protection that you couldn't get otherwise. And if you really think about it, a bumper is just sort of a rudimentary way of providing protection. If you take a regular laptop and you put a bunch of big fat bumpers on the corners, then you would have better protection if that machine was to be dropped on its corners. One of the things that we learned a long time ago was that by integrating into the design, again, this is a purpose-built machine. If we know that a machine has to be designed to withstand a drop, then you can make a machine a lot smaller, thinner, and lighter if you integrate the entire machine to handle a drop, as opposed to taking a machine that wasn't designed to handle a drop and adding some bumpers to it. Now, if you were to look at like our ToughPad G1 10-inch tablet, that has some corner guards on it that sort of look like bumpers, but the whole design of either a Toughbook or a ToughPad is protecting the electronic components in that machine, typically without having something really as sort of rudimentary as a set of bumpers to do that. But in the testing that we've done specifically against competitors like GTAC and Dell, the testing that we've done shows that the level of integration that we have, the wireless testing capability that we have, the experience we have in sunlight viewability and in end-user interface, the experience and investments that we've made actually makes our machines more reliable than those machines, and that's one of the reasons that we share our failure rate data, and we haven't seen any of our competitors being willing to do that either.
Okay. Are you seeing any demand for the Android operating system from the Department of Defense, and is supporting Android on your radar screen?
We do have a couple of machines that support the Android operating system. We find that most of our DoD customers still prefer the security and manageability of the Microsoft operating systems. The vast majority of our DoD customers have recently made the change from Windows XP up to Windows 7. And while there is some demand for Android OS, the vast majority of military users, from a security, manageability, and interoperability perspective, are still choosing to use the Windows operating system.
Okay. Question from the audience, and that's in terms of flexibility to integrate with other systems, and how easy is it to integrate the Toughbook with other military systems, particularly computers that might not be a COTS or an open system? I mean, is it difficult to use a Panasonic Toughbook in a WinT network, something like that?
Well, one of the benefits of using a standardized operating system from Microsoft and having Intel architecture in our machines means that our interoperability with other systems is extremely high. We do have some customers who are using some Linux systems, and we've got driver support for a number of the Linux systems out there. But from an interoperability perspective, because of our industry standards from a hardware and software perspective, most of our machines drop almost completely seamlessly into the infrastructure that our customers might be using. So there are very few issues with that. And as I mentioned, we have this extensive network of field engineers who can help our customers handle any integration issues that might arise. Okay.
We're coming up to the top of the hour. I think we may have time for one or two more questions. I've got one here from the audience. Tablets are becoming a very popular option. Do you see rugged tablets replacing rugged laptop computers in the next few years?
We do see some places where tablets are being used in place of laptops. Over the years we've done a lot with convertible tablets, and some of those convertibles are shifting to more of the slate tablet types of designs. But we also find that the keyboard has a high level of comfort for a lot of users. So we think that many of the tablets that get used may wind up getting used with some kind of connected keyboard with the tablet. So a convertible or a two-in-one, something like that, may see greater play. But for a lot of users, the clamshell or laptop design with its full-time attached keyboard, and oftentimes with these larger screens, can be very attractive, especially if you're talking about things that are being mounted in vehicles and aren't being used on the move, but are more used in the vehicle or on a desk or table, and not being used on the move. Tablets are particularly good when you need to do data collection on your feet. And so we're seeing a lot of deployment for those kind of users, but still a very strong number of traditional laptops being used out there.
Okay. And on the topic of questions, Kip, it's very typical for us that sometimes even the majority of our registered webcast attendees will come in to look at the presentation on demand at a later time in the evening or whenever they can. If those people, I noticed that you have your email address up on the slide that's showing now. Would you welcome email questions from some of our on-demand attendees who were attending at a different time?
Yeah, absolutely would. And if people have specific questions for different departments or that kind of thing, we have a full team of sales and support folks who work with our DoD and federal civilian customers. So I can take those questions, and if they're not questions I can answer specifically, I can certainly pass those along to the appropriate people on our federal team.
Okay. Got one more question here, and it's kind of looking to the future. I mean, we've seen, the evolution of laptop computers to tablet computers. What about things like wearable computers, wearable devices, and those types of things? And really, kind of, what do you see in the future in terms of mobile computing that the military is going to be pursuing?
I think we are going to see, more wearable computers as the size of computers have come down. We sell a product today called the ToughPad M1, which is a 7-inch tablet, roughly the size of an iPad mini, if you will. But it's got a full Windows operating system and an Intel Core i5 processor in it. And there was a time, and it's a completely sealed, fanless design, there was a time that we would not have been able to get that type of computing technology into a device that was that small and that had that kind of thermal envelope on it. So I think we will continue to see further miniaturization, and that will allow things like wearable computers. Part of that investment that we're making in R&D is in developing new styles of wearable computers that can be worn on the body or on the helmet of a warfighter. And so we're going in that direction to help people become more hands-free and to give them access to critical information and data when and where they need it, and oftentimes without actually ever having to lay their hands on a computing device, but one that will be accessible to them on their body. So I think you will see some further developments over the next couple of years in that area, and I think that Panasonic is well positioned to lead the way on that. We've recently brought out a new body-worn camera that is getting a very enthusiastic reception from a lot of law enforcement agencies. And it's part of our Arbitrator line of evidence capture devices, and it's one step in that move toward full wearable computing devices.
Okay. Well, I wish we had time to get to additional questions, but unfortunately, I think we're just simply out of time. So on behalf of Military and Aerospace and Electronics in Penwell, I would like to thank today's presenter, Kip Walls, Director of Product Management at Panasonic System Communications Company of North America, and our sponsors, Panasonic and Microsoft. This presentation will be archived within 24 hours and can be accessed on demand from the home page at www.militaryaerospace.com. A reminder email message for the archive will be sent to registrants, complete with a direct link to the archive. We thank you for joining us today. I'm John Keller, Chief Editor of Military and Aerospace Electronics.